how does science work? How do scientists like myself and the people we're going to be learning about come to conclusions? And I want to differentiate between facts and the process. Scientific facts can change. Unfortunately, you're going to be tested upon facts, but you need to know that some of these facts may not really be facts. We saw that, for example, with Barbara McClintock, who discovered, against what people had thought, against popular idea, that the DNA can change. Originally, her facts were not believed, but now we know that that really is a scientific fact that DNA can change. So what is the process of biology? Well, there's two general processes, two general approaches to science. One I'll call discovery science. This uses induction. This is what Darwin did when he went out on the Beagle. He didn't have any grand hypothesis. He started collecting data, and based on this data, through induction, he developed new theories and new hypotheses, which then could lead to experiments. This is the same type of approach that's used in the modern genome project, where they're developing huge or gathering huge amounts of data, huge collections of gene sequences without any real hypothesis. The hypothesis comes from analyzing the data. But the approach used by most scientists is what I would call the deductive approach, where we're using hypotheses, hypothesis-driven science. And I would just give a very simple example. Let's say that you're sitting watching this, and let's just say it's 9 o'clock at night wherever you are sitting. And as you're watching me speak, you're yawning. You're getting very tired. Now I want your thesis, your master's thesis, to be about why are you tired at 9 o'clock at night while you're watching Daniel Shamovitz teach what a plant knows. Now to develop your thesis, you're going to need to develop first hypotheses, and we can think of several hypotheses. Maybe the first hypothesis is that Shamovitz is a rather boring teacher. Well, I'd rather think of a second hypothesis. The second hypothesis could be that you woke up too early in the morning and that's why you're tired. So now what experiments can you design to test these hypotheses? Let's go to the first one, that I'm a boring lecturer. So the obvious experiment would be to do is to switch the lecturer. So you'll go back to the Coursera homepage, choose another course, and start watching it. You're still yawning. You're still tired. Now, does that finding prove that I'm not boring? No, unfortunately not, because he could also be boring in the next lecture. So you do a third lecture, and that lecture also causes you to yawn. So does that mean that I'm not boring? No, it could be that she was also boring. But if you do this enough times, and each time you're still tired, you've realized that you don't have enough proof to actually support that hypothesis. So now let's go to the second hypothesis, that you woke up too early in the morning. What would the experiment be? Well, again, it's pretty obvious. Let's say you don't wake up until noon the next time you watch my lecture. And now you come to the lecture of Shamovitz and What a Plant Knows, and lo and behold, you're full of energy. So what's the result of your experiment? The result is that you were tired because you're not getting enough sleep. So that's on a very simple level. And what we want to see now through plant biology are what are the hypotheses that lead to the findings that we're going to be talking about.